We have another super interesting talk. It's called Migrating to Polkadot, a complete guide. So during this talk, different approaches to migrate a parachain from Kusama to Polkadot are going to be outlined by our next speaker. And so our next speaker is Harald Heckmann, head of blockchain engineering at Zeitgeist. So please put your hands together to welcome him to the stage.
Hey everyone. Here it's Harald from Zeitgeist. Today I'm going to talk about how to migrate the parachain, essentially from any relay chain to any other relay chain, but in this context from Kusama to Polkadot. So I appreciate that all of you are still here listening after this long and exhausting day. We are all quite tired, so I think I want to try to give you a little thank you gift at this point for appearing here after that long day. And so want to celebrate this unique gathering of unique people in this unique event, trying to push the boundaries of uncertainty of a unique ecosystem with a little improvised beatbox session. I have no idea what's going to happen now, so let's enjoy this unique moment.
Polkadot Decoded. Polkadot Decoded.
That's it. Okay, so this, so it's the topic's migrating a parachain. This is Polkadot Decoded 2023. My name is Harald Heckmann, working at Zeitgeist. So what we want to talk about today is we have this setup. We have one relay chain A. It's Kusama. Assume this is Kusama. This could be Kusama. On relay chain B, this is Polkadot, and we have a parachain on relay chain A, and we want to get it over to relay chain B. Get it over from Kusama to Polkadot, for example, right? So question is, how do we do that, and what are the challenges associated to that? I'm going to use the term source relay chain and source parachain and target relay chain and parachain in this talk. So one approach that you could take is copying the data over. So basically you replicate all the complete state of the source parachain on Kusama to the target parachain on Polkadot. And you could use a script to copy all the data over. And the other approach that you could take is you could re-anchor the parachain, basically not doing any copying, but just imagine it like reattaching it from one relay chain to another relay chain. So the copy data approach would use a script, read all the data from the source chain, get it on modify it to be correct on the target relay chain, and then sequentially write the data to the target parachain. The problem with that is that the execution time on a block is limited. You just have so much computation, like block space, every block, and you cannot copy all the data in one go. So you have issues with atomicity and consistency of data when copying the data. So this approach is like not something that you should actually do. Then with the re-anchor approach will work like that. The relay chain actually always stores the latest state and the latest state transition logic with the runtime inside its storage, and you can actually set the state and the state transition logic on the relay chain. And to the parachain that you want to migrate. So you basically let the Polkadot say to Polkadot, listen, my parachain is now the parachain that lives on Kusama, and then you just connect them together. At this point, shout out to Kilt, because they were the first ones to execute this approach, and they actually discovered that one. So good job on that. You can see like a sequence diagram here that shows one source parachain on Kusama, the target parachain on relay, the target parachain on Polkadot, and the target relay chain Polkadot. So the re-anchor approach would be the source parachain adjusts the configuration of itself, of its own storage, in a way that it's valid on the target relay chain on Polkadot. Then it stops the block production to avoid any state changes during the migration. And once that's achieved, and the source parachain doesn't produce any blocks anymore on the source relay chain, Kusama in that case, you instruct the target parachain to tell the target relay chain Polkadot that it wants to update its own state, its state transition logic, the runtime, to the latest ones on the source parachain that you just have adjusted and stopped previously. And after that's done, you just connect the source parachain using a chain spec to the target relay chain, to Polkadot, and the block production can go on. That's the whole idea of like how the re-anchoring works. So there are some challenges with that approach, and one challenge is you have to have a plan B. If you mess up, your chain halts, and then it won't produce any blocks, and nobody wants that. And you could use governance to recover that, but it will take some time. And we have to shed light on how we could do this, prepare for this situation. Then aligning the state might be a problem, because what do you have to actually change in the storage? And depending on the context of the migration, these values could also differ. How do you actually halt the chain to avoid like state changes during the migration and to avoid double spans and forks? How do you override the state and the code of the parachain that you want to migrate on Polkadot? And how do you connect the source parachain finally detach it basically from a network perspective from Kusama and attach it to Polkadot? So how do you connect them in the end? Yeah, here we are again. We have nothing. We want to migrate. We just have one source parachain that we want to get to a target relay chain from Kusama to Polkadot. So you could recover using governance. This is pretty slow. We don't want that. Instead, we can use the manager account. Who is the manager account? Who knows what the manager account is? Let me see that. One person, two persons. Okay. And some that don't raise their hands, I'm pretty sure. But the manager account is something that's not very known and famous, but it's very, very powerful and should be used with caution. But in this scenario, it's very helpful. The manager account is the account that registered the parachain ID of the parachain in the first place. And the parachains can instruct via XCM to unlock their respective manager account. So in this case, we have a source parachain on Kusama that we want to migrate, and we have a shell parachain on Polkadot that we want to replace during the migration. And both of those parachains, they send the instruction to the respective relay chain, Kusama and Polkadot in each case, via XCM to unlock the manager. And this makes the manager almighty, because once you unlock the manager, you grant him superpowers, and this is stating the state on the relay chain of the parachain he's responsible for, setting the code on the relay chain for the parachain he's responsible for, and at this point I can tell you the manager can do anything with the parachain, because he can specify the state, and he can specify how the state is changed in each state transition. So he can essentially do anything. Then you can swap leases with another parachain, the privilege to produce blocks. And finally, the manager can also withdraw the superpowers from himself. We are interested in the first two superpowers, because should we during the migration mess up anything, and we end up with a halted chain. Then we can use the manager account to set the state and the code of the halted parachain that failed during the migration to a previous block in the history, and actually revert to a time where it still worked and fix the issues that occurred. Then the next problem is aligning the state. So essentially, I can't give you like a perfect solution that works in any case. So you have to figure that out. What exactly you have to change in the storage so your source parachain on Kusama can actually function on the target relay chain on Polkadot. But some things that always change, that you always have to consider, are the parachain ID in the storage within the parachain info palette. You have to look into the last downward message queue head and then the HMP message queue head. So basically, this is like the those both variables contain hashes of that represent like the latest state of the XCM interactions, and they have to be equal on parachain and relay chain. So you have to adjust those values on the source parachain to match on the context of the target relay chain. And in case you use auto-inherent or Nimbus, you also have to adjust highest slot scene. But those are some values that you always have to change, except in the case of Nimbus. Of course, you have to use auto-inherent. But this is not like what you can rely on in every situation. You have to test a lot and figure out what kind of state adjustments, storage adjustments you actually have to execute. Those are just some examples. Then halting the chain, we have explored 3 solutions so far. So one solution is the intrinsic halt. You are adjusting the storage could result in an inconsistent state that stops block production due to panic. To be more precise, when you change the parachain ID or the XCM heads, it's called like that, and it results in a mismatch between the heads that are stored on the parachain and on the relay chain, then your node will stop producing blocks because it assumes there was an attack because there are different heads on the XCM message queues. This doesn't always work, so you can't rely on that. Then there's another solution. Okay, I have like 2 times 0.1. So the second solution is halting by transferring the slot leases. So you can actually register a second parathread, a parachain ID, spawn like a shell parachain on that, and then just transfer the slot leases, the privilege to produce blocks, from the parachain you want to migrate to your recovery parachain that you just registered. And that way you withdraw the rights from your parachain to produce blocks, and consequently it halts. Problem with this solution is that you have to lock funds to actually register parachain ID and register the runtime, the genesis state and WASM. So this is like, yeah, this requires funding. And then there's another solution. You could also halt the chain by setting an invalid state on the source relay chain. So basically you say, Kusama, the state of my parachain that I want to migrate is now another one, the state hash. And after that, it will result in a mismatch. Your parachain has another state than the one registered on the relay chain. And this will also halt the chain. The problem with that is that you have to have very good timing about when you do it, because the node, like the validator or the collator in the case of a parachain, the collator, could overwrite the state, and this would result in other problems. But if you want to know more about solution 3 and how it works exactly, then please go spam Flat from Subsocial, because he actually was successfully executed that solution, but it's not documented anywhere yet. Then the chain is now halted. Now what we want to do is so our Kusama parachain is halted. What we want to do now is we want to tell the target relay chain Polkadot that what it has to expect, what kind of parachain it will serve from now on. And to do this, you go to Kusama, you get the latest head from your parachain that you want to migrate. You get the latest runtime code that was deployed on your parachain on Kusama. And then you overwrite the target parachain code and state on the target relay chain on Polkadot, matching to the values you retrieved just for your parachain that you want to migrate. You can do this using the solo to para palette, which I recommend because it's like everything is timed correctly using that palette, and there are no unexpected surprises if you do it properly. Or you could execute the runtime upgrade and afterwards use the manager account to set the state on for the parachain on Polkadot, but I don't recommend going that path because you could also mess up timings here. So now, once we have done this, we arrived at the situation where our parachain that we want to migrate has been adjusted properly to operate on Polkadot. It has been halted. We have told Polkadot what kind of state and runtime logic it has to expect now. And the next thing and the last thing that we want to do is actually, from a network perspective, connect the halted parachain that was prepared for the migration to the target relay chain to Polkadot that was also now prepared for the migration by setting the code and the state. And this is pretty straightforward. All you have to do is you take the chain spec that you used previously, and I've marked some lines here that are important. The protocol ID, which basically identifies, like it's a unique identifier for the network, the parachain ID, and the relay chain the parachain operates on. And in the case of Zeitgeist, we just applied a new unique protocol ID. We adjusted the parachain ID to the one on Polkadot, and we said the relay chain is now Polkadot. So once you execute this chain spec on the data, like using the data of the halted parachain, it will connect to the target relay chain, in this case Polkadot. And since you adjusted the state and the runtime logic on Polkadot for the parachain already, in case you did it correct, it will be also able to go on producing blocks. This is, I'm going to skip the recap, but because the time is running out. But just quick. Ensure you have recovery, align the state on the source parachain, halt the source parachain, make the target relay chain Polkadot aware of what state and code it has to expect on the parachain that has to be migrated, and then finally, from a network perspective, connect the parachain to the target relay chain, Polkadot in that case. So this is an immensely complex operation, so I cannot emphasize enough how important testing is here. And the most time should be spent in testing and actually executing this process with the team. So use a test environment that is as close as possible to production. You might use something as ZombieNet or Chopsticks for that. If you implement a solution like that, let me know. We did it by hand. The thing why it should be as close to production as possible is that we did it on Rococo first, like on a fresh instance of Rococo. It worked. We did it on a production clone of Polkadot. The chain halted during the migration process. So don't do it like on Rococo and expect it will work, or in a new environment. Do it like as close as possible on production. You can open the slides later and see the exact steps we did as Zeitgeist. In Zeitgeist. But I want to move to the last point, and this is communication and transparency. Test it with the whole team and assign roles. Everybody should have done the migration and test environment once and should know what to do. You should repeat it. Create a step-by-step checklist so you can go through that when things are getting real. Practice, 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 practice. Provide instructions and documents as early as possible to all roles in the network. And finally, be transparent and update the status to everybody. So that's it. Thanks. You can find some links here. And here's the QR code to the slides so you can get the details that I just skipped during this talk. Thank you, everybody.